All right, shall we start? Good morning, everyone. Welcome back from the summer vacation. Right. First of all, I would like to briefly introduce the project and the schedule for the data collection for the upcoming semester. And Locky will be running the workshop, all right, to introduce to you the SmartPLS. This is the tool that we have used to do the data analysis. All right, this is the workshop overview. I would like to take you through to the data collection plan for the new academic year and briefly remind you of the research design. All right, you should have been informed already before. The tools for analysis, what is SmartPLS, and you will be given some time to do practice with authentic data, right? And a Q&A section and way forward. All right, this is the project title. Pilot study has already been finished, actually by the end of August, all right, from late October last year to end of next month. The main study will be commencing from September this year onwards, all right, at least for 1 or 2 years, all right, at least for 1 or 2 years. Scope of the pilot study, that what we did, right, in the last semester. Evaluate learning transfer. We did some data collection for CUE students and Common Core students. And we also investigated 2 education ED courses and how students perceive learning transfer in their courses, ED courses, to the faculty courses. We also investigated students' perception on the learned skills they find transferable in both CUE and education ED course and the extent of transferability. And for the time being, the project team, Paco's team, and also Clarence ED team have identified some areas for improvement in their courses. Right. Project deliverables. We would like to develop better teaching and learning materials of CUE and education ED courses, and we'll be writing up a brief report to Miranda, all right, to actually to come up with theoretical framework, how we come up with this framework, and how we are going to improve the courses. Okay, data collection for the new academic year. That's what we completed, all right, just to remind you what we did. For CUE, we did 2 rounds of e-survey, 70% response rate, right? And we did focus group interviews with the CUE and Common Core students. And actually, we analyzed the interview transcripts and we identified some themes for Paco's reference. And individual interviews with the Common Core teachers. And we also collected some student samples writing to help us triangulate the data. And for 2 ED courses, education ED courses, we did an end of course e-survey with the students, just 1 round, not 2 rounds, right? And with the current ED students and the students from previous years. And we also conducted focus group interviews with the ED students. And Locky has kindly identified some key themes from these qualitative data, and the data has been sent to Clarence's team for data analysis, for further data analysis. All right, for the upcoming year, semester 2, 2 PCs will get involved in the project. Education, Clarence and Eleanor. All right, thank you very much for your support. Our Clarence team at the other 2 ED courses. All right, this is roughly the number of students. And social science, Eleanor identified great speeches and report writing. All right. Are these the number, roughly the number of students?
For CAES 9421, is speech and hearing science as well?
Oh, yes.
I think
9421 is speech, 9423 is education.
But the number of students I think should be, should be 140.
Should be 23, 9423, 140.
Oh,
yes, the other way around, sorry.
Yeah.
Yes, you're right.
Okay, yeah.
Okay, thank you. I'll make the change. Semester 2, 3 PCs will get involved in the project. Ken Ho, Eleanor, and Colin. Right? Colin has already identified 1 ASK course, about 160 students. You told me 8 to 9 classes.
Yeah. Usually right. it varies, but yeah.
All right, that's the rough number. All right. Why we need to know the total number of students? Because this may have some impact on the analysis. Locky will tell you in a minute. Ken Ho identified 2 engineering courses, and Eleanor will be having psychology course, all right, in the second semester. All right, okay. All right, tools for analysis, PLS model. What is SmartPLS? So I'll pass the time to Locky.
Thank you.
He will tell you more.
Right, I'll give you the hard copy first.
I would like to remind you, you do not need to do data analysis. Locky and our team will mainly run the data analysis for PCs and for your team.
Great, thank you.
And after we identify the themes, we'll pass the data to the PCs. And if you would like to get involved in data analysis together, of course, we're very happy to work together to collaborate. All right. And also, if you find these two a bit technical, no problem. All right, no problem. I think you have the right to know more about why we use this tool, and we have the responsibility for showing you how we use this analysis tool to do the data analysis.
Okay, thank you, Natalie. All right, I just want to borrow that last slide. One of the main reasons why we want to use this particular software or the PLS modeling algorithm is exactly what it says here. If you apply this method, it only takes you minutes. And this is precisely why I want to do it, because most of the classes do not come with the sample size like the CUE, which is like over a few hundreds. So for conventional, what we call covariance-based modeling, for that you usually need a large data, whereas for PLS or this particular software, you don't need that large sample size, which is perfect for ED courses. So let's get started. So this is the link to the data set. If you have the laptop, could you please now download it? Basically, it's a zip file, and then after you have unzipped it, you will get the original questionnaires that we use for CUE and the ED course. But the most important thing are these 3 Excel files. The data collection was done using Google Forms, and then everything's collected will then appear in the kind of like a spreadsheet format. So this is basically what it looks like when it's raw. The questions are on top, and then the answers are, in the form of a 5-point Likert scale, and they're all text. So what we need to do is we need to transform all these we have to transform all these text data into numbers through coding. So if I make this a little larger, you can see these are the numbers that will be replacing the actual answers that the students have provided for us. So strongly agree 5 and strongly disagree 1, basically 5, 4, 3, 2, 1. And there are other categories, so maybe DSE grades and IO. So we just give each of them a number. And after we replace, also the faculty, we also give them a number. So after we've done the data cleaning and the coding, and it should look something like this. Basically, you will see a lot of numbers. Right, and so that's the first thing we need to do when we get the data, and then we also replace the questions with something that we can identify with. So UL 1, 2, 3, 4, 5, and then all the way to then you have another one we call TA, and later we will go into these little parts there. But as you know, you can see that basically numbers except for the first row. And then after this, we save it as CSV file, because the Excel file cannot be imported to the software, so we use the CSV file, which is also very commonly used in SPSS. So then it looks like this, basically the same thing. Okay, so this is the one that we need to use in our workshop today. Now there are 2 CSV files included in the zip file. One is the here it says it's a CUE retention survey version 1. Basically, this is something that I generated using an original pilot data that we collected from the CC course. So basically, after the first round, I generated some samples for it, just to test out whether our theory will work or not. Okay, so let's go back to the main concept to begin with. Basically, more or less similar to the covariance-based structural equation modeling. You get some bubbles and you get some rectangles, and you get some, E's numbers. If they are bubbles, they are basically what we call the latent variables, which are basically constructs that you cannot really observe. So you have to find ways or questions to measure them. Then the questions that you want to ask are going to be in the rectangular boxes. Okay, so these are sample questions that actually measures this y1, and then sometimes y1 and y2 will help you measure y3. And some of these will come with E. E means the error. Okay, so in SPSS you have to key in the error, but for PLS you don't need it. So it's just hidden, but it's there, and it'll be all calculated for you. So basic concept is we have the bubbles that is measuring other things. They are called the exogenous latent variable. If they are bubbles being pointed to, like y3, they are called the endogenous latent variable. So we can look at some examples. Y1 here, if you look at it, this is called a reflective measurement model, which you look at these questions. I appreciate this hotel. I'm looking forward to staying in this hotel. I recommend this hotel to others. They basically are more or less the same questions, measuring the same thing, but they are being asked in other ways, different ways. But you can take away either one of them, and it will still be explaining the same thing. Now, this is called reflective. And if you pay attention to the direction of the arrows, it's basically from the bubble to the rectangles. The other one is formative measurement model. Arrows are pointing towards the bubble itself, and then the questions are different because you have to ask several questions to form this particular construct. Whereas the reflective one, you can delete one or two, it will still be valid, so to speak. Okay, but whether you want to remove any of these, we'll have to look into the statistics, but that will be very advanced. So, but for now, we just need to know the concept. So there are two main ones: reflective and formative. Are we good?
So what's the construct?
Construct, you can say it's a concept. So you want to measure this concept.
I know what
Sure.
I mean, in this particular case.
Oh.
It was. Would it be I like the hotel or something like that? Or?
Well, if I appreciate the hotel, maybe satisfaction.
Okay, satisfaction.
Maybe this for reflective one, maybe satisfaction. If it's service personnel rooms, maybe quality.
Quality. Okay.
Yeah.
Right.
So it could be these two.
So it's kind of higher, more general. Level.
Yes, exactly.
Yeah.
So this is just repeating. So you have different things measuring the same construct. So reflective measurement, and we've looked at that. Or this one also is reflective. This is how much you like about the hotel, for example. The third one, single item construct. This is something that I don't think we will need to, pay attention to this or pay special attention to this one, because we don't normally want to measure a construct using just one item. It's just not too, persuasive if we do that. This one here is customer satisfaction. That's CUSA, and the other one, CUSL, is customer loyalty. So customer loyalty, they decided that they want to have 3 items to measure it. By the way, these items in the rectangle, they are questions, and we also call them indicators. Okay, so there's another term for that. We also call them indicators. So this is just like some of the ways that you can form these constructs or measure these constructs. Okay, so what? After that, very basic concept, then it's the sample size. So how much is enough, right? For the ED courses, as I've noticed from Natalie's presentation, so if most of the time we get over 150 or over 100, then that will be, in general, will be adequate to, because if we want to measure significance level, we look at 5%. As usually that's the case, right, for a significance level. And then we would say, so if you can see these numbers in under 5%, they are usually, there are a lot of them are lower than 100, but we don't want to look at these because we want to look at the most precise ones. So if we want to measure the R square, which is basically the higher the better, but here we're looking at the precision, so how precise this is. So we want to get the most precise R square, and then so we look at this column, and what we can see is if we want to measure let's say we have 2 questions we want in a construct, then it is advisable that we have 90 usable observations, so we have 90 students' responses. And the rest will be like, as the number of questions you want to ask increases, then the number of observations that is needed also increases. So it's advisable that we get around 100 usable data. Now, what if the course itself is, has fewer students than 100? Then what we could do is we could try to find 2 ways. One is we can find courses that are asking similar questions. I don't know. Maybe these 2 courses are both under education, and so there are overlapping questions. If we are overlapping questions, we can then put them together. Then that will add up the data. Or you can then say, I can measure maybe 2 semesters or 3 semesters or 4 semesters of the same course, and then you stack up the numbers. So it doesn't really matter if the students come from different years, but all we mostly care about is, do we have a total number of samples that meets, let's say, 100, usable ones. So that's the most critical, because afterwards even though we combine them and they are from different years or different semesters, we can then use group analysis to separate them, and then we can compare them separately. So the most important thing is we have a total number that meets about 100. So what there is a rule of thumb. It's called the times 10 rule. So if you're asking 10 questions, then it is advisable you have 100. If you're asking 9 questions, then it's advisable that you have 90. The times 10 rule. But what we're talking about is 5 questions or 10 questions we're referring to questions pointing to one construct. Which means if you have 4 constructs and some other constructs, they are asking, let's say, 4 questions, 5 questions, 6 questions, that's okay. We're looking at the maximum, the largest number of arrows pointing at one construct. So that will be our needs. Okay, so is that okay?
Can I just ask a question?
Sure.
For example, if you want to get 0.1
Yeah.
at 0,
Yeah.
okay, that means 90 people would have to answer 2 questions.
It means that it would be necessary that if you want to ask 2 questions, it would be necessary to have 90 students answering that question. But if you
sort of kind of go against what you'd sort of logically think, wouldn't it? That you'd expect the more people answer the same questions in the same way, then probabilistically, the more reliable you would think it would be. But you're saying no, it's not that. It's actually you need more questions if you have more people.
You ask more questions, you need more people.
Yeah.
Yeah.
To make it more to get
exactly
to make the probability more reliable.
Yes.
Okay. I mean, that seems a little counterintuitive for people who are maybe don't know much about statistics and probability.
So sorry if I didn't make that clear. Yeah, but basically,
I'm just double checking. It was clear, but I was just double checking.
Okay.
Yeah.
Perhaps because these questions are not exactly the same. So they're trying to represent the same construct in a very similar way. So the more questions you answer, the more observables you need, or the students you need, so that they can still be kind of pointing.
Okay.
Yeah.
Yeah.
I mean, this is how I
Exactly.
I know this.
Okay, so
it's
it's
kind of think of it in another way.
Yeah. Okay, so you're getting more sort of points pointing towards this
Tying all
construct.
these variants together.
Yeah. Okay, so there's an idea maybe that you have more people and they conceive of these.
At the end, it's better to have 100 people answering 10 rather than like
2 people.
2 people
90
answering 2.
people answering 2.
I mean, that's the.
But in the end, more people's better, right? Because
Obviously,
yeah. But
that's right.
More people, more questions is better. Yeah.
That's right. So because this is like 0.10, this is like the kind of highest precision that we want. If it's exploratory, you can go lower precisions. So then you need fewer observable data. So which is why you can see even down here, if your precision is just at 0.75, and then you only need 18 for 10 questions. But this won't be, I think, something that we are aiming for. We usually aim for the higher precisions. So that's why we want to aim for the
p-values,
numbers.
are they?
No, these are not p-values. These numbers are the number of usable observations that we need Basically, it means that
I mean,
90 students.
the one 0.1, that's the p-value, is it?
That's the R square.
Oh.
That's an R square, but don't worry too much about that. But basically, it means the higher the R square, the better. But if you're looking at precisions, that means the lower is better.
Yeah. I get that, but I'm
Sure.
just thinking, so that's similar to the p-value in the sense that the probability is
No.
higher, no?
Not the same. Sorry, not the same. They're not probability. Yeah, but I'll explain later. Sorry.
I have a question
Sure.
about what counts as a question. For example,
Uh-huh.
in the CUE questionnaire,
Yeah,
there
sure.
are 4 constructs, mainly 4 constructs, and each construct consists of, for example, like in some cases there are 4 questions and 4 items.
Yeah, excellent. So Eleanor is referring to this questionnaire. This is the CUE questionnaire. So we have here. This is one construct that measures. This is the formative. So we have A, B, C, D, E, F, G. That everything is different, right? Some parts are measuring formulating stands and synthesizing ideas. So this is the formative. So Eleanor, your question was the reflective questions.
Well, yes. Well,
Okay.
going back to
Okay.
to the statistical level, because so for your exhibit like 1.7, you are
Okay.
saying that if you have 10 questions, if you want to
Yeah.
reach like a 0.1 significance level, you better have like 150 something
Yeah.
participants. Are you talking about one construct? So if under that construct you have 10 items, that means your N should be at least around 150.
Yes, in a sense. If you use the time 10s rule, then it's at least 10 questions, at least 100. Will be good. Obviously, the most precise one would be 156, as they suggest. But we're just looking at maximum number of arrows pointing at a construct, so it can be any constructs. Which is why here, it's a great question, because when you ask that, then going back to our questionnaire, actually there are 12 different questions here. For formative, and then here which is reflective construct, we only have 4 questions. So there's 4 questions and there is 12 questions, but we only look at the largest one. So we only look at the 12 questions, and times 10 means we need at least 120 to make it reasonable or satisfactory. So is that right? Yeah. So you can have multiple constructs. You can have multiple different number of questions, but we only look at the maximum one, because that's the most troublesome. And we want to make sure that one can be calculated with certain validity or reliability. Okay.
I wanted to add something. Because CUE we have a large number of students. That's why we developed 12 items. All right, under question 4 and 5. Those 12 items are the learned skills in CUE, key learning components in CUE. So if you have a small course, we could reduce the number of items. Say only 4 or 5. We could narrow down the focus.
Yeah. So are we good? So then we can move on to the next part. Okay, this one we just skip it for now. Okay, so that's bootstrapping. We'll come to this part later. So let's start with our software. So if you have your laptop, we can now go to SmartPLS3. You can double click it, and then we'll come to this very lovely, clean, minimalistic page. All right. So let me just archive these. Archive project? Okay, great. So when you start, basically, if you're sitting too far, you can come sit closer, and then you can see the screen better. Because I cannot magnify this. Sorry about that. Okay, you guys okay at the back? No.
Perhaps
Yeah.
I can move this a little in front.
This one?
Yeah, the other day I did this
sure.
SIG, it was like right here.
Oh, cool,
It's easy.
cool. How do you do that?
Well, just move a little.
Thanks, Ken. Awesome. So I also need to move forward. Okay, great. So we all cuddle together, more cozy. Except Alice and Keith, like kind of out group. Okay. Right, so as you can see, there are 3 panels. There's the biggest one, which is where we will plot our bubbles and rectangles. But when you start, all you need to do is click New Project, and you give it a name. Let's say this is the first set of data that we'll use are the trial. Let's say just call it trial. Anything, So as long as you can identify it. So anything, and then right here, if you're looking at this panel here, this is going to be your bubble chart. So if you double click it, this is where you will plot the latent variables and rectangles and stuff like that. Okay, so if you double click this one, after you have, can we follow? Yeah. Okay, cool. And then here they say double click to import data. So just double click, and you open up that a dialog box, and then you choose the first one, which is CUE Retention Survey version 0.1 whatever. Okay, so but that's the first one that I generated it using preliminary survey results. So we can play around with this one first. Okay, so once you double click it, import, and you press OK, whatever name it is, doesn't really matter. And then the descriptive statistics is automatically calculated for you. So which is why this is like so cool. You don't need to worry about whatever. It's mean, median, mean, max, standard deviation, kurtosis, skillness. If you need it, it's right here. Okay, so you don't need to do anything. And I think all software should be like this because they know you're going to use it. So why not calculate it for you? Okay, so but that's this. We don't need to look at it very much. As long as you can import it, you can see this, meaning the import is successful. So you can close it. And then we go back to our bubble chart. Now, remember that we have 4 constructs, right? So if according to our concept, we have the 1 bubble here, 2 bubbles, 3 bubble, 4 bubble. So basically the 4 latent variables. Now we can change names if we want to. And if it's wrong, you can delete it. You can then click select, and then you can right click and rename. Okay, so you can just give it a name like that. Right click here, rename, and because our first one is content relevance, so we just type content relevance, or if you like, you can say CR, just give it a name. And then here, again, you can give it another name here. So this is applicability, transfer applicability, so let's just call it applicability, TA. And here is, all right, I forgot that one. So let's do this one first. This one is transfer outcome, or just outcome if you like. TO, and then what's the last one? TA, TO, TO, UL, understanding of learning. Okay, so rename understanding of learning, and then you can say UL, for example. So the most important thing about using software, or actually not using software, but planning the whole research is what's the theory. Now we call this a theory, so we have the target latent variables that we can measure, we want to measure. And we chose these 4. There are actually many others that you can measure: motivation, or satisfaction, or teachers' performance, that kind of thing. We chose these 4 because we don't want to touch on the other ones. Because if we say we want to measure teachers' performance, that's going to get people in trouble, right? So things that is within our control, content relevance within control, applicability kind of within our control, how they understand their learning, that's on them. And most important thing is the outcome, so that's on them as well. Okay, so that 4 bubbles. And then what's the hypothesis? Once you have the hypothesis, then you can click on the connect and start connecting these bubbles. So our hypothesis was that content relevance will affect applicability, how relevance in your content will affect how they apply their knowledge, which is in common core courses, and then also content relevance will affect their understanding of learning. Their understanding of learning will then affect the applicability, because if they don't understand, they can't apply. And how they understand will affect the outcome of their transfer. And finally, how they apply can also affect the outcome. Okay, obviously, content relevance can also directly affect transfer outcome like that. So then you have the 4 bubbles. The direction has to make sense. Yeah.
All right, I want to add something.
Sure.
These are the constructs we use in CUE and
Yeah.
education education ED courses, if you think you may want to develop another framework or constructs, I think that would be fine, all right? Because we recommend you to do this, to follow this, because it works quite well in the biggest course in the university CUE and also the 2 ED courses. Like some PCs would like to find out like motivation factor or other factor you would like to explore, that will be okay.
Yeah, sure.
All right, 5 constructs or even 3
Yeah.
constructs.
So this is something that the PC has to think about. You know, how do you want these constructs? Do you want to measure something else? If you add motivation, there will be other path. Then you have to come up with your theory, and that has to make sense. Okay, but by the way, if let's say I now tagged it this way, I don't like this arrangement, I can drag and drop. So, which is very easy. If you are using SPSS, you probably can't do this. You know, you can adjust it whatever you like, however you like. Okay, this is very easy. And then, now if you have used SPSS before, you know that you have to click these rectangles one by one, and then you have to click arrows one by one, unless you have a plugin. But now for SmartPLS, you don't have to do any of those. All you have to do is you come back to this little panel here, which are all the indicators. Indicators are basically the ones that you have imported to the system. So you get the, let me see, this is the understanding of learning. So I just highlight them, right? Shift and highlight, and then just drag them into their corresponding boxes. Okay, so that's like that. And yeah, and then so A is applicability, done, and then CR1, CR5, content relevance, transfer outcome here. And then, now basically if you don't care about the interface, you're done. That's the end of mini workshop, bye-bye. You know, so basically this is the end. But obviously you need to make it look better, so you can then click that construct, right click, and you just make it look better. So you can align the indicators on top, align the indicators to the bottom, align it to the left, right, bottom, right. And then so it's as simple as this. And then don't forget there's one more step. Can anybody remember what this step is? Formative and reflective. What do you need to do?
Change the angles.
Thank you. Change the angles. Change the arrow direction. So then you have to remember. So content relevance is reflective. So reflective pointing outwards is correct. But here, understanding learning and applicability, these two are formative. So you need to reverse these arrows. Again, right click and switch between formative and reflective, and done. So that's 1. That's 2, and then we can calculate. And then we press calculate. Now there are a number of options, but for as long as we are working with formative, if we're working with formative, we only need to choose the original PLS algorithm, and then everything stays default. You don't need to change anything. Start calculation, and bam, you get all the data analyzed basically. So everything's calculated. You have this and you have that. You can click various different stuff and you can get all the data. If you go back to the bubble, and then all the numbers are on there. So that's kind of like the end of what you need to do with the software. The next step is just looking at the statistics and numbers and knowing how to analyze it. But that's all kind of like the end. If you're using SPSS, probably doing. Let's just say you go back to the pure reflective one. This one will probably take you at least 20 minutes or at least an hour just plotting things. And if you change anything, you need to type another thing. You can redo the whole thing, and this is like just seconds.
Blue one, I've got a number on that.
Yeah. So are we okay with the software here? This is like kind of like 50-70% of what you need to do with the software. There's one more thing that you may want to do. It's called bootstrapping. So bootstrapping will give you more precise t values and p values. Everything stays default. Press start calculation, and then you wait a little while, and then everything will be done, and then that's it. Okay, so that's done. And then you get all the p values, t values, and we will learn how to read them later. But to be very superficial, and no, let's say I don't know anything about statistics at all, look at colors. If the colors are green, p-value colors are green, means it's okay. That's it. And you have, let's say you have effects. If you want to talk about indirect effects, then p-values are green, means it's okay. Loadings, I don't know what loadings are, let's say, but I don't care. I only care about is it okay or not okay, looking good or not looking good, all greens, no problem. So everything is pretty much self-explanatory. If you don't want to go into the details of statistics, and then you get all these green color, red color, black color. They will tell you whether it's okay within range or not within range, that kind of thing like that. Which is why this is so cool. You don't have to worry. If I'm not a statistician, can I understand this? Yes, you can, because all you have to do is just present these numbers, and they're all there for you. Now, if there's not, if it's out of range, it will be red. Sorry, Ken. Yes.
Sorry about interruption.
No problem.
Well, I mean the mechanics are good, and it's very, very, very good software. But I guess the key is how valid. Can you go back to the bubble?
Sure.
In defining this model, and in setting up the constructs, and defining the relationship between them, for example, the applicability, does it always have to be going into from the understanding, whether it can also have another arrow going up to actually affect the understanding of learning when you can apply certain things. So how do we ensure that, the questions will be addressing the bubble correctly, and the relationship between the bubbles are actually valid?
Very good question.
And if that doesn't work well, the mechanics will not work well either.
Very, very good question. Now, yes, so when you first have your own theory of what construct you want to measure, and then what construct is affecting another construct, you have to be very clear in your own mind, this is what I want. But the reason I use this generated data is I also have doubts, because maybe it doesn't work. Maybe my prediction that this affecting this one, it's not valid. Then what should I do? Maybe the direction shouldn't be CR pointing to UL. Maybe it's UL pointing to CR. It could be like that. So by using it can go both ways. So which is why if I have first I have this generated data based on real data, I kind of like extrapolated it, and then I can test my so-called my theory to see if I need to make any changes. Now. So if I'm wrong, let's say outer model, inner model, let's say I don't want to show t-value, I show path coefficient and p-values. Let's say here, because I was going to go into how to read these numbers, but for now, let's just say we have all these 5 paths. Is it 5 paths? Okay, six paths connecting these 4 bubbles inside. So we only look at the ones inside here. Right. If it's close to 1, okay, then that means it's a high level of relationship. If it's close to 0, then it's basically almost like no relationship. If it's negative, close to 1, then it's opposite direction. Which is why that will answer Ken's question. If I have I use real data, small sample, but I kind of generated more for this purpose, then I can test whether these are okay. And because I did run the test, so I can see that none of these are negative, which means my prediction is relatively reasonable. Obviously, some of the connections are a bit weak, so 0.3 is kind of closer to 0. Then I'm kind of, I have to ask myself, does it make sense? If understanding learning does not directly or does not strongly affect transfer outcome, does that make any sense? Which means if somebody understands a topic or understands an item that you teach, hedging, for example, so the student understands hedging, does that mean that it will automatically yield an outcome when he goes to common core courses and apply? Can he, without application? I understand. Therefore, there's an outcome. Yeah. Does it make any sense?
Yeah.
So if you think, oh yeah, it actually doesn't make much sense, it will kind of affect it, but it will not affect it directly or strongly, because if you understand, you don't apply them, how do you know that there is an outcome? You can't say, I understand this, therefore there's a yield. Doesn't make a lot of sense. So this is reasonable that it is lower. And exactly that is what you want, because you don't actually want everything to be very high. You want everything to make sense. So if it makes sense, for example, content relevance will strongly affect the understanding learning. You want that to make sense and it's high, it means it's good. If this number is low, then you have to start thinking, like, what's wrong? Is it because my theory is wrong? So if your theory isn't wrong, then the questions might be wrong. So this is how you go backwards and then start thinking. What the numbers are telling you, they're just indicator for you to evaluate your own theory and going back to see if the questions are wrong or not as good. Obviously, then these are these other ones that linking the yellow boxes. These are called the outer model ones. So you can also look at other. You can also look at weights and loadings and something that's I'm going to go into later. But basically, each individual questions, they all have their own numbers. So they will help you find out which questions might have problem, or you haven't planned it. Maybe it's overlapping and you don't want that, or maybe there's a wording that's not quite nice, and so the students give you some weird data. So then you can go back using these numbers. You can go back and then evaluate that question again. Which is why the pilot is important.
Can you take out some of the so-called invalid questions and then we calculate and remodel?
Yes.
See the whole thing.
Yes.
Okay, two of the
Sure.
10 yellow boxes are not good.
Yeah.
So let's take them away and then see whether that actually affects the correlation and even maybe proving whether the directionality is valid or
Yeah.
not.
Now I'm a little bit reserved about the word correlation because PLS doesn't do correlation. It is a prediction model, so it doesn't mean that. For example, if the content relevance is higher, then the understanding of learning will be higher. It doesn't mean that. It's not a correlation-based modeling, but it's a prediction-based modeling, which means that if you have a sample set that gives you a certain a strength of relationship, okay, then you can put some other student with similar characteristics, and you can predict what their understanding level is, what their outcome would be, how much they could apply. So in a sense, is in that particular inquiry, rather than this one goes higher, so that one will also go higher. It doesn't mean that. So it's a predictive-based modeling. Do you understand? Do you know? Not really sure.
Not really sure.
Okay.
It sounds like correlation the way you say it, but.
It's subtle. It's subtle. It sounds like it's correlation, but it's not, because in PLS basically it doesn't mean that. How should I put it? Okay, make it very simple.
Is it a tense thing?
In a correlation-based
You've got the line.
modeling, in a correlation-based modeling, it's that if something, let's say, if I have more money, I'll be more willing to spend. That's like a correlation. But if I have less money, I might be less willing to spend.
Yeah.
So in that case. But that is only done because you have collected a certain number of data, usable data, and you calculate it within that data. But if there's somebody else outside that sample, let's say Natalie is not a student, if I ask her, she might, can I apply this model onto her sample? Cannot. That doesn't apply because she's not within my sample. So a covariance-based or a correlation-based one, you don't really consider anything outside the sample because your sample is the best you can get.
Okay, yeah.
But for predictive modeling, is that if you have 600 students, like for CUE, and you use them to calculate all these predictions, and you get some other students from another year, let's say you teach them one thing, citation and referencing, that's it. You give them one thing. They tell you, oh, I think I understand that much. I understand 80%. Then basically, immediately you can use this and you can predict how much they are likely to yield that outcome, and then how likely their applicability is, even though they're out of sample. Because this is a predictive modeling.
Just basically,
Yeah.
It's a tense thing, isn't it? That's you've got this is what happened.
Yeah.
There's a correlation here, but you're saying this is what will happen or could
Yes.
happen.
Again, probability-wise.
Yeah.
So it could happen. But if you increase this, does that increase the other one? No, it doesn't. If you increase content relevance, does that increase understanding and learning? You can't say that. without these strength of relationships. So, and everything will change as well, right? I mean, other things will change as well. So it's not exactly the same as correlation, so to speak. One go up, the other one will go up. Or one go down, the other one will go down. No, it doesn't. So in a way that they're not exactly the same. Yeah. Okay. So hope that is not as confusing as it sounds. And it's because there's a lot of statistics in the background. So I try to not talk too much about the concept, and hopefully just enough for you to understand what it is. Okay, so just now we were looking at we mentioned about bootstrapping, right? We say we can go to calculate and press bootstrapping. Basically, what bootstrapping is that we have our theory, our model. Okay, the 4 bubbles, 5 bubbles. Okay, and then we have our original samples. So what bootstrapping does is they keep drawing from random samples from our original samples and replacing them, and then they come up with estimates for our constructs, and then you repeat. So by default, it's like 500 repetitions. So what the computer does is from your sample, drawing different questions, drawing different students' data, and putting them together, calculate. And then another one, do it again, draw, calculate, and then come up with another estimate to give you that precise, what we call R-square. How strong that matches the whole sample. But if you do a lot of random samplings and then you get the averages and then you put them together, stack them together, you get a more precise look of what it is. Instead of doing one average for everything.
Is that also to sort of take out things like outliers that might just in one reading, right? And you have outliers that it would sort of skew the...
Exactly. So we try not to skew it, and by a lot of doing a lot of repetitions. For us, we can do 5,000, and pretty easily the software can do it in 1 minute, and then you get 5,000 repetitions. Yeah. So you can adjust that here. Just now by default was 500. If you are really into precisions, you can do 5,000. And then the interesting thing is you can then look at through comparison, what's the difference between the 500 and the 5,000 one in terms of repetition and then the p-values and everything. Because usually the more repetitions you do, the more precise you get. And then you can look at the precision and say, oh, well, actually, do I need to do 5,000 next time? Or maybe 500 is already enough. So something like that, you can compare. So we don't have to wait for them, where we can just continue. So that's basically the concept of bootstrapping, by drawing samples and doing a lot of calculations, repetitions to get the precise values of your data. Okay, and last, okay. So this is the last basic concept, is reliability and validity. So something that's reliable may not hit the bullseye. It's just grouping together, and something that is valid will be reliable and hitting the bullseye. And if not reliable, it will be everywhere, and it will never be valid. So basically, if you're looking at reporting reliability, this is what it means. If you're looking at reporting validity, this is what it means. So we always want to achieve valid data at the same time. Obviously, it has to be reliable. Okay, but not reliable, then it's definitely not valid. So that's what this diagram is talking about. Okay, so all right, so we've just completed the 5,000 repetitions. So then, if you have time, you can then compare the numbers. But basically, that's what it does. A lot of statistics. How strong it is, how weak it is. So there is that. Okay, and then everything will be shown here. And if you like, let's say I don't like to read numbers, you can then go to highlight path, and you choose use relative values or absolute values, and this one basically shows you the strength. The thicker the line, the stronger the strength it is. So you can then, from a snap, I don't care numbers, I can then see, content relevance will affect my understanding learning the strongest, and then followed by others that are relatively weak.
Why the question? The indicator lines. Why are they suddenly? I mean, if you're just trying to find out the relationship between the constructs, why suddenly these lines?
Sorry, which lines?
These lines have become thick, right? But are you not just measuring the? Why are these ones?
Good question.
Ask a simple question.
Very good question.
Why are these ones thick? Why are these
Thank
ones
you.
thin? Yeah.
That's a very good question. Now, Actually, same as the ones that's inside. These ones that is in the outer model, outside, we also look at whether it's 1 or 0 or -1, right? So if they're close to 1, that means they are very strongly related. I don't use the word correlated, but they're strongly related. And we want them to be close to 1. And that's why they are so thick now, these lines. And because these are reflective questions, and we look at the questions again, we can then see here. Okay, these are the, let's say here, content relevance reflective questions. So basically same stuff that we ask, but in different ways. And if they are all very high, and that's what we want, and that means that we ask good questions. But if suddenly, let's say the last one, CAES 1000 is well aligned with my Common Core course curricula. Let's say this one is particularly low in here. Let's say CL5 is the lowest one, right? Let's say so, and it's affecting our model. Then you may want to consider going back to the question: what's wrong here? You ask yourself the question: what's wrong here? Why is this one giving me weird outcomes? So you may want to go back to the question. Maybe I didn't ask correctly. Maybe I have a typo. So various reasons. So because this is pilot.
So would that mean that you would? Oh, because it's a pilot.
Because it's a pilot, I can then change it, and then I can go back to get more data afterwards. But if this is final, which is unlikely, because you want to do a pilot first, right? But it's unlikely that you get weird data in the end. But if it's pilot, then you may want to consider, okay, maybe I don't want to ask 5 questions. Maybe 4 questions are enough. Then you can look at the lowest one, and I say, okay, then maybe the CL2 is the lowest one. I don't want to ask this question next time. You can delete that, and then therefore correspondingly, I also delete that one, and then I can do a recalculation, and then you can see what the numbers are like again.
What the effect would be.
Yeah, exactly. So in the pilot stage or the planning stage, this is what you can do.
Any colleague has told me you would like to do a pilot in semester 1, right? In one of your classes.
Yeah.
I think that you can
Sure.
Use this idea.
Yeah.
Yes,
I understand
That is some of the
the
questions.
reflective
Yeah,
one.
around the
I mean,
preliminary
on the right,
analysis.
so maybe based on the internal reliability in some way, then the computer can know that, okay, these 4 questions are very similar, the other one gives a very different number in terms of the negative number, so they take it out. But for the formative one,
Yes.
okay,
You can't take them out,
so
so to speak.
how does the computer actually know that these questions, the yellow boxes, are good representation of the blue bubble? The blue bubble, if they're not even comparing among themselves, they're all thin.
Yeah.
So how does the computer know that basically the yellow box does not represent the blue bubble?
What happens? Yeah. What happens is if you, for our real data, let's say now we want to drop this particular data set. So let's say I want to delete that because this is a generated one. So let's say now I want to go to the actual one. This is the actual round 1 CUE data, and then so then we can because we have already changed a lot of things. The number of questions are different, so we want to do it again. Actually, you can start a new project and do it again. But to answer Ken's question, basically is if it's after calculation, you'll see that maybe this one, for example, will be low or negative in a sense. So then you will see that this is not a good representation of that particular construct.
But they're all thin.
Sorry?
They're all thin.
All thin.
They're all thin.
You mean that the lines are thin?
Yeah. If you look at the numbers,
Yes.
they're all still not high.
Sorry, I deleted the one just now. But here, if you remember, this is all the thick lines, right?
Right.
The thick lines, because these are the reflective. So then they will be thicker. But formatives, they don't kind of show very good thickness here. So you have to look at the numbers from the calculations.
Oh, you
So it's better to
some
look at
of
that.
these thin lines or arrows, actually, they have good numbers?
Yeah.
Oh,
Sure.
okay.
So,
It just doesn't show it visually?
visually, they can't show negative, so they would just be one line. If it's negative, it would just be one line, just like any other near 0 ones. But if it's close to 1, then they will have thicker lines. So in a sense, that doesn't show very well. If it's negative, it doesn't show very well on this.
But if you go back and show
So let me
all
just put
these
it back.
here,
Okay, let's just put it back, and then
Yeah, put it back. And
TA.
I'm a bit surprised that you see all the thin lines, you see all the low numbers there. That means that they are not really representing the blue bubble.
Right,
I
let's
mean,
see.
the yellow ones, they are not formative enough to represent the blue bubble. So basically,
Okay,
we're asking a set of questions that are not as meaningful.
Well, I would
represent
rather, well, yeah, I would prefer to look at the numbers itself than the chart.
Maybe I'm
But
wrong. I mean, maybe the numbers are good rather than the thin lines showing up.
But then you need to know something about the numbers. Then you need to sort of start. Is that right? You need to know
well, because actually the one about thickness. I mean, the line thickness is something that is for presentation purposes.
Maybe.
So if it's we are doing if we're doing analysis, we'll just go back to the actual numbers. Let's just run 500 again without the. Now you can see some red ones. So
If they're all
anyway.
thin, then basically the arrows are not meaningful.
So if you want
We're
to,
asking a lot of
like that,
questions
yeah.
which don't
So you can-
represent the blue.
so you can see that here, right? So some of these are pretty thin. Because this is okay, you can change to relative, but it doesn't. You can see then there is a slight difference in terms of thickness, but they're not very obvious.
Yeah, that's what I mean.
Yeah.
Like visually, it seems to me that it is represent the thickness in certain ways. I mean, it's not like for the reflective it shows the thick lines, but for the formative it doesn't show the thick lines.
No.
It also shows the thick lines.
Yeah,
They
but
are thick.
not as good. Yeah.
So that means that all these yellow boxes or questions on top for this particular understanding and learning construct, we're not really asking the right questions.
No. Oh, I finally understand what you mean. Okay, so sorry about that. Here.
None of the questions have a good correlation.
That's a very good question. Here we want to look at something close to 1 and 0. We want something close to 1. 0 not good. Negative means we have the wrong direction. So yeah. Now for formative, there is a limitation for formative. Formative, the maximum number allowed for formative, it's 1 over the square root of the number of questions. So if we have 12 questions, then the largest number permitted on each of these is 1 over square root of 12. So that would be the maximum number for each of these. Which is why now, if we going back to Ken's question, why is it so thin? Everything is so thin. Is it not a good representation? No, because the formative are restricted by the calculation of formula, which is that 1 over square root of n. That will be the maximum number.
12 is like 3 point something at least.
Yeah, so 1 over something like that. So
the square root of 12 is 3 point something at least, right?
yeah,
So
and then 1 over it.
117
So
compared to 3.
1 and then 1 over. So maximum allowed is 0.28. So 0.28 is the maximum allowed in each of these. Yeah. So
But the numbers still seem quite low.
Still seems quite low.
Yeah.
Still seems quite low.
So
But is it also something to do with the relationship between the items and the construct? Like,
This is what I'm saying.
yeah,
You-
I mean, is it like that thing? What's that called? That analysis you do with the items, they check the items against other items or something.
Bootstrapping.
Internal reliability, that kind of
Yeah.
thing.
That's I can understand for the reflective
Yeah, the
ones.
reflective one I get,
There must be
yeah.
a few thick ones and then
Yeah.
you get the thin ones.
Yeah,
But
that's
for all the thin ones,
great.
To make up that.
then basically you're not asking any
Weights.
relevant enough questions to represent that group bubble at all.
Now, so that's why this is the moment when we have to actually go into the actual numbers, because by looking at the chart, it doesn't represent, it doesn't tell you very good, and also you might have to move around too much just to get that little number to look at it, right? So we want to go to
Just go straight to
go straight to bootstrapping, and then we look at each of these and how good are their p-values. And now what is this? Now outer weights are measurements for formative. Okay, so weights only measure formative. So just now the question was on formative, are they good enough? So then we can look at the p-values and t-statistics. Basically, the higher the t-statistics, the more likely the p-values will be valid, right? So you can see, okay, this is 50 something is really good. 3 point something t-statistics is barely okay, right? But then if you look at the next one, okay, below certain values, right? So 0.2, that is definitely not okay. So you can see there's a red p-value. So then that will be an indication of something is wrong with TA10, which is applicability question 10. and then also 3, 4, 5, 6. Then you have to go back to look at the questions again. So why is it? Now, there are several reasons why this could happen. Obviously, if you have already done the pilot phase, you have done the calculation, it seems okay, but when you get the actual numbers, they turn out to be red. Then you have to look at it. Why is it like that? Is it because these questions, remember, they're formative questions, so they should have minimal overlapping areas. So if your questions are asking, for example, one is, let's just imagine, right? So if this TA3 is on, no, let's not imagine. Let's just go to, imagining will be,
let's do
let's do the real thing. Let's do the real thing. Yeah. So TA3, so 1, 2, 3. So this one. Distinguish between main and supporting ideas in academic resources. Now, does this overlap with other questions? Maybe 4, 5, 6. Does it overlap with any of these in certain areas?
Maybe synthesize ideas.
Yeah. Maybe synthesizing ideas is actually kind of like related. So that's something that we need to look at. If we want a really perfect model and perfect questions, then we try to minimize the overlapping areas, be very specific with what we want to ask. But if it's unavoidable, then
probably unavoidable.
Yeah, if it's unavoidable, then we stick with what we have. Exactly. So, but then how do we justify whether we want to keep this question in our model? Now, we look at the weights. The weights tell us that there are overlapping areas or some other issues there. So they're in first indication. But do we need to keep it? We go to loadings. Now, loadings are for both formative and reflective. So if they're all 0.000, if the sample mean is over 0.5, you keep. So the appropriate assessment for various things. So we have validity and reliability and discriminant validity. Yeah. So then you have you can click at all these buttons, because outer loadings is a button right here. Outer loadings. So you can look at these criteria, and actually you don't need to look at criteria really, because it's all green. So you just look at color. Okay, this is a pass. Yeah, this is a pass. This is reflective. And then AVE, look at AVE. So should be somewhere here. Here. Okay, sorry. So we have the AVE. The matrix will give you the numbers actually. The AVE is also here. Composite, reliability, complex alpha. So everything here, if it's all green, that means you got a pass. So here, just check. Okay, composite reliability is here. So green again, good. Complex alpha, green, good. HTMT. Then you go to here, HTMT. So then you go. Okay, look at this. If it's red, then you have to go and see, okay, what's happened? Is there something wrong? So then you can evaluate. So basically, that's the indicator. Then you have the, how do you evaluate autoloading? Further analysis. Then you have formative assessments. So that's the Ken's question. So how do I know whether that is too close to each other? So if the questions are too close to each other, we will have a very bad collinearity. So we then go to collinearity statistics. This is for outer ones, and that's for inner ones. Basically, then they give you all the combinations, and they kind of tell you whether the constructs are highly collinear or not so collinear. And we don't want them to be collinear. What it means collinear, it means that your questions are overlapping too much, causing the weight to be red color. Then you have to go back and check the questions. But here, even though we have some red, and because the loading is higher than 0.5, we keep all the questions. And because both inner and outer VIFs are good, there isn't any red, so that means our constructs are okay, even though some might be overlapping. So which is why there are like multiple tests or requirements to help you. Do step by steps and see how much it is, how good is good, and when is it not good, when do I have to remove it, when do I have to maybe change the entire, if you're unlucky, when do I have to change the entire theory itself. But because we have done the pilot, then we can avoid that complete change of steps. Yeah. So there is this. I'm not going to go into all these little details, but basically because you have the hard copy, also you have the soft copy. Basically, it's just going there and then check. Oh, is this good? Is low? Is medium? And kind of, really self-explanatory. Even though if you don't know anything about, details of statistics, it's just looking at colors. So green, okay, black. Green is good. Black is okay. Red is not good. So then, if it's red, what do? Then you go back to this, and usually it's going back to the question and check, and then see if other things are okay. If other things are okay, we keep. So we go by the flow chart, as recommended by the authors from marketing. Yeah, there you go. So there are steps for you to follow, and it's not difficult. That is only if you want to analyze it yourself.
Yeah.
Again, it does only if you want to analyze it yourself, which you can.
It takes practice. Yeah.
But I think we know enough what we can ask you to help us do.
Yeah, that's true. That's true.
But I know that you can check these things to see what you can.
That's true.
So,
That's true.
What exactly will you be doing? You will do this data analysis for us, so we.
Mm-hmm.
Yes.
Okay.
So I think for
If
PC,
we want to check you're allowing us to that option of checking ourselves as well. Or
yeah, exactly. So if you want to try that by yourself, obviously that would be really good. Yeah. Then you can basically plug in the data, and then you can see. Oh, okay. I can just look at the parf, and then relative. Oh, that's really good. That's what I want. And this is very low, and it makes perfect sense because this is something I want it to be low. For this is understanding of learning, going to transfer outcome. I want this very low because it makes sense. And this one I want it to be very high because content relevance should strongly affect understanding of learning, like that. And then content relevance should strongly affect outcome as well. So you can see what you want to see. And if it's against your theory, then you can go back and look at it. Obviously, the other things are, pretty okay. We only look at negative. Negative not good. Why 6 isn't good? You can go back and ask yourself.
There, that's a very weak relationship, is it?
Sorry, which one?
The applicability to transfer.
Okay. So the inner model, applicability to transfer outcome.
Why would that be weak?
Yeah. So that's pretty interesting, right? Because here what we're seeing is this is a direct effect. So the direct effect from applicability to outcome is low, but that doesn't mean that the overall effect is low. So, which is why then, if you want the detail, you can go to total direct effect. Then you can see the overall effect, the overall strength of the effect. So, because there is individual effects called path coefficient. So that is ignoring everything else, only from one bubble to the other bubble. So that's the path of coefficient. There's the indirect effect. You can total up the indirect effect. So that will be in between. Let's say, okay, let's just go back to this one. If I want to measure transfer outcome, actually. From content relevance to transfer outcome. Actually, there are many paths that can be taken, right? So it can go here, or here directly. So indirect effects will be not considering this, but in the effect in the middle, minus the original one. The effect through others. So that will be indirect effect. And then when you add all the effects together, then you have a total effect. So for us, the most important thing is whether the total effect would be high. If the total effect is high, is good, then that is the most important. And then if even the total effect is low, then we have to take a look at the question and see why, or think about why they are lower. Now, so if we look at total effect, applicability is giving low transfer outcome. So this exactly stays the same. Whether it's individual or indirect or total is still low. And then you have to think about what it means is that students who applied or who get to apply, they don't see the outcome. Who get to apply, they don't see the outcome.
They've applied what they've learned, but they don't see it as an outcome, or they don't feel it.
They don't feel it.
We can do something. PCs can do something.
Because this is a perceived answers.
An example. Give me like a
okay.
citation or something like that. What would that mean?
Oh, you said citation, it will be very high.
Yeah.
Not citation, but
stance.
Yeah, okay.
Oh no, speaking tutorial, for example. Speaking. overall speaking. So when we go to look at the data from focus group and interviews, well, students are saying that speaking, is okay, but because we usually do debates in common core courses, and you don't teach debates. We don't do academic discussions. We just do chats, in our common core courses. So they learn it, they understand it, they can't really apply. Therefore, the outcome would be low. So we trace back to the question, then we know, that's the one because that's the reason. So which is why the focus group will help us understand better. And this will be the indicator of something is going wrong, and we know exactly which part will be wrong. But
so then you
why?
Can go to qualitative data.
Yes. So don't forget we have the qualitative data to help us answer the questions.
Yeah, you can't just rely on this.
But planning the questions for qualitative analysis, so for focus group and individual interviews, basically it would be very useful to go back here. So we look at, because we will expect the students to give us good answers on questions related to content relevance. We expect them to give us good questions, good answers for understanding learning. So what we want to focus on is the ones that are lower, and we want to check with the students, like exactly what Colin's asking. Why is it that do you feel difficulties in applying your knowledge to common core courses and therefore getting the outcome? So the questions will be more direct,
I'm just
more directed to that.
Not the numbers, but the intuitive level. I'm looking there and going, all right. So there's the content is relevant, and that means that they feel that they can transfer what they've learned.
Content relevance is strongly related to our transfer outcome.
Okay.
How is it strongly related? Because it could also go for the other path. Because content relevance will help them in understanding learning, and then understanding learning help them in applying. So because there's one path and there's two paths, so it could be either way.
If the content is relevant, it could facilitate the transferability.
Okay.
Yeah, but they are seeing a low transfer outcome. Even though they understand, they think they can apply, or they can apply, they still think the outcome is a bit weak. From if they want to judge from an applicability point of view, it could be because they didn't take a course that requires them to speak academically. They took a course that didn't that actually asked for debates and presentations, which we don't teach. So that explains why this is low.
All right, don't forget, statistical data are scientific. We still have the qualitative data. Say, for example, in the focus group discussion, before they start the focus group discussion, we ask them to do some short reflective writing. Those reflective answers are very useful to express their views, why they thought perceived that the course can be transferred to other contexts, what skills they could transfer to other contexts. I think those data are very useful for your report or for your course development. Yeah.
Oh, absolutely. I mean, I think you can't just use the statistical data alone. But like you say, it can help inform.
Yes.
Or make you go back and look at the qualitative data, perhaps.
Yeah, to the advantage of having the PLS and then all these different indicators with numbers, they kind of help you focus on what to ask during that focus group or interview. So we can see that we will kind of place less attention or more general questions on understanding learning, content relevance. But we'll focus a bit more on transfer applicability, and then the questions in the focus group will then lead them to give us the answers to verify whether what we see in a chart is correct or not. So you can see we have a lot of questions on transfer applicability. Is it because of this? Is it because of that? And also on transfer outcome, because we have to know both ways, right? We have to know. Why do you think that you're applying? You can't apply. Is it because you can't apply, or you can apply, but you don't think that you yield any outcome?
Yeah.
So that will go under transfer outcome.
One other question, because you said you're triangulating the data, so you've got your statistical quantitative data, you've got these focus groups and interviews. But you said you're also going to look at student work as well.
Writing sample.
How will you be analysing that? Will you be looking for the features? Will you be quantifying that?
All right, in the next round of data collection, it would be good if PCs could collect the sample writing before the focus group discussion. So before the discussion, Locky and I could have a look at a sample and we could ask specific questions based on students' writing.
So what we did was we Sure.
This is student writing from their Common Core courses or from the CUE?
Faculty.
From the faculty.
Yeah. So what we did, we asked Common Core course teachers to give us some samples, and then they were showing us like, so here are the things that is typical of a good writing for from their perspective, and then they can see because they do this. So the teacher actually tells us what they appreciate as a good piece of writing, and then this is not good sample because they don't have this, don't have this. So they will also kind of like co-analyze with us. Yeah.
And
to a certain level.
Before focus group discussion, we could ask the participants to bring along the sample writing.
Oh, okay.
Yeah. Or show us the sample writing before.
Great. I mean, even that alone itself is very
Okay. All right.
Sure. So I think that's all. Basically, if you're just looking at how to operate the software, it's just a 2-minute thing. So click, connecting that, put the data, press the button, that's it, done. So the more tricky part, will be just knowing how to read the numbers, and actually it's not difficult either now.
All right.
Yeah, because we have the slides to as reference, so it shouldn't be too bad, right? Yeah. So just need to go back to these tables, and basically you have all your answers. So it's not difficult. But that's it.
Now you know how SmartPLS operates and you know the concept. And I think later this month or next month, I will have a meeting with individual PCs to talk about your roles in the project and how you would like to get involved in the project. And Locky mainly will do the data analysis for us, all right? And if you understand more about the concept behind, you could still raise any question, or if you would like to modify the framework, I think this would be good, all right? And one more thing, I would like to thank Locky.
No,
he has done
it's
lots
okay.
of work.
No worries.
In terms of
Oh, come on. No, come on. I'm just doing my work.
Yeah, he's really an expert in
no problem.
statistics.
No problem.
We're lucky to have him in the project.
Come on. This is too much.
And we have done the pilot. We still have much room for improvement in the project in every aspect. So feel free to let us know, all right, what else we could improve, and we could do more to further improve, all right?
So I'm looking forward to seeing your theory in the sense that what are your constructs and what do you want to measure, basically? Yeah. I think the constructs are the most important. So what affecting what? That would be the starting point.
Yeah.
And also the most difficult and also the most time consuming, but also the most challenging and interesting part.
Yeah, the rewarding. Yeah, you can get it right.
Yeah, because you don't have to follow our 4 bubble. You can you can try some other things.
How many bubbles come with that?
We came up with the 4 bubble from a total of 81.
81 bubbles.
We have a total of 81 bubbles, and then we pick 4.
Whoa.
Measurable and won't get teachers in trouble,
Oh right, yeah.
Thank you. Thanks for coming.
In the summer.
Yeah, thanks for coming.
Thank you.
Thanks for coming. And play around with the sample. Thank you. Play around with the sample data.